Hello,
Good evening, sir.
good evening. Do you have any doubt from last class? Nabila?
No doubt, sir.
Okay. So we have completed up to this part. A submarine is at depth of 20 meters from sea level. Find net force on its side window whose area is 20 centimeters square and inside pressure is maintained at atmospheric pressure. Let me define you how to approach this problem. Suppose this is sea level and there is submarine at depth of 20 meters whose window Okay. So suppose there is outside pressure as P absolute and pressure from inside is maintained as atmospheric pressure P naught. So you'll get net pressure that is P absolute minus P naught. Area of cross section of this window is given as 20 centimeters square. Then you will get amount of force acting on this particular side window pane using P net equals to net force exerted by area of cross section. So F will be equals to P net into area of cross section. Is it clear?
Yes, sir.
Try to solve. Sham, just check your calculation. If you calculate absolute pressure, so it will be P naught plus rho GH. So net pressure acting on the window pan will be equals to P absolute from outside and P naught from inside. So it will be P naught plus rho GH minus P naught. So this term and this term will cancel out. So you'll get rho GH only. Rho is density of water. So it will be 10 to the power 3. G is gravity, 10, and H is depth of that point, which is 20 meters. So on solving, you will get 2 into 10 to the power 5 Pascal. Raza, is it clear?
Yes, sir.
Now, area of window pan is 20 centimeters square. So if you calculate it in terms of meters square, just multiply it by 10 to the power minus 4. So you have pressure and you have area of window pan. Just put all the values in this part. You'll get net force acting. Good, Sham. So force equals to net pressure, that is 2 into 10 to the power 5, into area of cross section, 20 into 10 to the power minus 4. So 2 into 20, it will be 40. 10 to the power plus 5 and 10 to the power minus 4. So it will be 10 to the power plus 1. So it will be 400 Newton. Good, Raza. Khalid, is it clear? Inashi?
Yes, sir.
Okay. You all have written?
Yes, it does.
Mazia, done?
Yes, sir.
Okay. Suppose the average surface area of human body is 1.5 meters square. Find net force acting due to atmospheric pressure. Try to solve. In this question, you have given area as 1.5 meters square. Value of atmospheric pressure is 1.013 in 10 to the power 5, or just use 1 in 10 to the power 5 Pascal. Area is 1.5 meters square. Just multiply these two terms, you'll get net force acting. So it will be F net equals to P absolute or P atmospheric into area of cross section. So it will be 1.5 into 10 to the power 5 Newton. Is it clear?
Yes.
But still, we can't feel anything like this. Why so? So let me define you the process. Due to atmospheric pressure, net amount of force acting on human body will be about this range, which is very high or very large in magnitude, but still we can't feel anything because there is, suppose this is skin of our body on which there are some small pores, and just beside it, there is a tissue called adipose tissue. You must have learned about it, which is fat storing tissue. So air from outside enters through this particular pore to fill this adipose tissue. And there is also bloodstream along this side. So atmospheric pressure must be acting from outside, and from inside there will be two different pressure. One is due to amount of air filled in this particular adipose tissue, plus blood pressure must be applying along outward direction. So one is due to blood pressure and the other is due to air filled in tissue just inside this particular skin. So net force or net pressure due to these interaction becomes zero. That's why we can't feel any force or pressure from outside or inside. This is your skin. Is it clear?
Yes, sir.
Yes.
Just write it down. You all have written?
Yes, sir.
Minashi, any doubt?
1 second, sir.
Yes, sir.
Okay.
Done, sir.
Done, sir.
Okay. There will be another question related to this. Suppose a man is lying horizontally. So net pressure at this point, and at this point will remain same. 8 and 2. So pressure at this point, and this point in horizontal position will be equal. But in case of you will be asked why pressure at 2 is greater than pressure at head. So you will say pressure on head is due to atmospheric pressure only, but pressure at 2 will be due to atmospheric pressure as well as the blood stream above this whole body acting at this particular point 2. So net pressure at this 2 will increase by a factor due to blood pressure. So at head, pressure is due to atmospheric, but at 2, pressure will be due to both atmospheric as well as blood above it. So net pressure at 2 is more as compared to head. Is it clear?
Yes, sir.
Okay, just write it down. You all have written? Nabila, any doubt?
No doubt, sir.
Okay, next thing is Pascal's law. First statement of Pascal's law is for stagnant liquid or fluid at rest at same horizontal level, pressure will be independent of direction or pressure in all direction will be same. For liquid at rest, pressure at same level will be same in all direction. So you have to prove this particular statement. Suppose there is a container in which liquid filled up to this point. Now take a cross-sectional area. Having area A on which a force F is acting normally to it. Thus having area A, a force is acting normally to it. along this direction, F. Now we can resolve this particular term and area force in different component. Suppose this is strip, this is vertical section, this is horizontal section. Like this. So if you apply or resolve component of force, let's say force is acting normally to the surface along this direction. Inclination with respect to horizontal is theta. So if you draw a horizontal line and a vertical line, this theta will be equal to this term. So force is acting along this direction. So it will have a component adjacent to this will be F cos theta. And for this part, it will be F sin theta. Is it clear? Raza?
Yes, sir.
Similarly, we can resolve component of area as well for different direction. Theta having area A. So along this direction, component of area will be A cos theta from this point to this point, and component of area along this direction will be A times sin theta. Let's say this is surface 1, this is surface 2, and this is surface 3. Surface 1 having area A, surface 2 having area A cos theta, and surface 3 having area A sin theta. Is it clear?
Yes, sir.
Consider a strip having area A inclined at theta with horizontal. The force F is acting normally to it. Now, on the basis of which we have resolved these two different components. One is for force and the other is for area. So we have to calculate pressure on each segment now. Let's say for surface first. On this surface, pressure equals to force divided by area of cross section. Similarly, for second surface, is this one, that is base, on which force is F cos theta and area is A cos theta. So pressure equals to force divided by area of cross section. Cos theta and cos theta will cancel out, so you'll get F by A. Similarly, for third surface, that is surface 3, pressure equals to third surface having force F sin theta and area A sin theta. So it will be F sin theta divided by A times sin theta. Sin theta and sin theta will cancel out, so you again get F by A. Let's say this is equation first. equation second, and equation third. You will say from equation first, second, and third, P1, P2, and P3 should be equal. It means at same level, pressure in this direction, or in this direction remains same. Is it clear? Nabila?
Yes, sir. Clear, sir.
So from equation first, second, and third, P1 equals to P2 equals to P3. Means at same horizontal level, pressure will be independent of direction. In all direction, it will be same. Just write it down. You all have written?
1 minute, sir.
Okay.
Done, sir.
Minashi, you have written?
Yes, sir.
Okay. The other consequence of this particular law is sure, Nabila. If liquid is incompressible and enclosed in a vessel, if a pressure is exerted at any one end, suppose there is enclosed vessel in which incompressible liquid is filled. Now, if pressure is applied at this end, let's say P1, correspondingly, at this point, pressure generated along this direction will be P2 and along this direction will be P3. So according to Pascal's law, P1 must be equals to P2 and P3 as well. It means for enclosed vessel containing incompressible liquid, if pressure is exerted at any one end, it transmitted equally in all direction without getting diminished. Means P1 equals to P2 equals to P3. So this is another consequence of Pascal's law. Is it clear?
Yes, sir.
Okay. Just write it down. Then I'll define application of this particular law. You all have written?
Yes.
Inashi, any doubt?
No, sir.
Mohammed Khalid,
Yes, sir.
any doubt?
No, sir.
Okay. Now, on the basis of this, there is an application which is called hydraulic lift. Suppose tip of smaller piston is connected with larger. Like this, in which liquid is filled up to this level. Now consider there is piston at this point having area of cross section A1, another piston at this point Now suppose force F1 is applied along this direction like this. So it will generate pressure in this particular fluid. Since this liquid is incompressible and this vessel is enclosed, so it will generate a force along this direction at point this. So pressure at this first end or smaller piston and pressure at this larger piston should be equal. So if you calculate P1 equals to force divided by area of cross section, equation first. Similarly, P2 equals to force divided by area of cross section, second equation. So according to Pascal's law, pressure exerted at any one end equally act on all direction if liquid is incompressible and vessel is enclosed. So you'll say, since vessel is enclosed and liquid is incompressible, so according to Pascal's law, P1 equals to P2. So if you put the value of P1, which is F by A, and in P2, it will be F by A2. So this will be your final expression to calculate F2. Is it clear? Sham?
Yes, sir.
Okay, just write it down.
Done, sir.
1 minute, sir. Done, sir.
This particular instrument is used to generate large amount of force by applying very small. Let me define you using a problem. Suppose if the ratio of radii of smaller and larger piston in hydraulic lift is 1:3. Find force on larger if 20 Newton is applied at smaller end. Just use the above formula and try to solve. In this question, you have given F1, that is force on smaller piston, as 20 Newton. Ratio of radii, that is R1 upon R2 equals to 1/3. So use this above formula to calculate F2. So you'll say F1 over A1 equals to F2 over A2. So F2 will be equals to F1 times A2 divided by A1. F1 times A2 is area of circular piston. So it will be pi r square divided by pi r square. Pi and pi will cancel out. So you get F1 times R2 divided by R1 whole square. Now put the value of each term and simplify it, you'll get F2. Good, Nabila. Good, Aksham. Good, Minashi. Raza, just check your calculation. Ratio is R2 over R1 whole square, but you have given R1 upon R2. This is R1 upon R2. Good, Mazia. F1 is 20. R2 over R1 is 3 divided by 1 square. So it will be 20 into 3 square is 9 by 1. So it will be 180 Newton, which is equals to F2. Good, Raza. So just see in this part, initially, we have just applied 20 Newton, but at larger piston, 180 Newton will be generated. So this instrument is used to generate large amount of force by applying just a small fraction of it. Is it clear?
Yes.
Next is acceleration of liquid. Suppose there is a container in which liquid is filled up to this point. And it is accelerated along horizontal direction. By some acceleration A. So to find how the level of this particular liquid will change or it will remain same. Initially, level of liquid is along this direction. Now, we have accelerated this particular whole container towards right side. So is there any level change in this particular liquid, or it will be remain as it is? Nabila?
So could you repeat the question?
Suppose initially liquid is filled in this particular container. So level on either side will be at same since there is no any motion in this particular container. Now it is accelerated by some A along horizontal direction towards right. So is there any change in level of liquid at both ends, or it will remain same?
There is change, so
So in which direction liquid will rise up?
right side.
Right side. So it will be like this. or it will be like this.
I'm sorry, left side, so left side.
Good. So this particular container is accelerated towards right. So due to pseudo force or due to acceleration system, there is change in level of liquid, so that level of liquid rise up towards this side. Due to which there is change in pressure. So if you draw horizontal line, so that this will be an inclination. This is H with respect to this point, and this is horizontal length from this point. So A will be equals to G times tan theta, or it will be equals to G times H by L. Is it clear?
Yes.
Okay, just write it down. You all have written?
Yes, sir. Done.
Raza, done?
Yes.
There is another question. Suppose at this point, let's say point A, you'll be asked to calculate net pressure exerted. So pressure at point A will be due to first, the amount of liquid that is above this. So it will be of vertical column H. So net pressure at point A will be due to rho GH due to its vertical column. Plus, there is another term, since due to this particular acceleration of liquid towards right, there will be force due to this particular column of strip towards left, which having length L and accelerated by A. So pressure due to this column will be rho A times L. Plus, there will be pressure at this point due to atmosphere also. So it will be P naught. Is it clear? So this pressure at point A will be due to vertical column. And this particular pressure is due to horizontal acceleration. And this is due to atmospheric pressure. Is it clear?
Yes.
Nabila, any doubt?
No doubt, sir.
Okay. You all have written?
Yes.
Raza, done?
Yes, sir. Done.
Suppose there is a cubical system like this, in which liquid of density rho is completely filled. Now it is accelerated along this direction. So you'll be asked to calculate, find net pressure at A, B, C, and D. So you'll say, let me define you for the first part, A. Pressure at point A. First, try to check, is there any vertical column above that particular point? So you'll say, yes, there is vertical strip at this point A, which must be applying pressure at point A. So it will be due to rho GH. Plus, is there any horizontal component due to this accelerated part? So you'll say no, there is no horizontal towards right side, which must be applying pressure at point A. So it will be 0. And since this particular vessel is enclosed, so there will be no atmospheric pressure acting. So it will be again 0. Is it clear? Mazia? Sham, is it clear?
Please repeat again.
Suppose if you have to calculate pressure at any particular point, so we have two different acceleration. First is due to acceleration due to gravity, which must be acting vertically. So there will be a pressure due to this vertical column of liquid. Second is, since this particular system is accelerating towards right, so the strip of liquid present towards right at that particular point will be generating pressure due to this part. So at point 4 point A, there is no any fluid towards right. So there will be no pressure at point A due to this horizontal acceleration. So this is 0. And this whole vessel is enclosed. So there will be no air above it. So pressure due to air must be 0. Is it clear? Nabila?
Yes, sir.
Similarly, let me define you for B. First, try to define, is there any strip vertically above? So you'll say yes, of length h. So it will be rho gh plus, is there any strip in horizontal direction towards right? So you'll say yes, of length L accelerated by A. So pressure at point B will be rho GL. And since this whole vessel is enclosed, so there will be no atmospheric pressure. Is it clear?
Yes, sir.
Minashi?
Yes, sir. Clear.
Similarly, if you calculate 4 point C, just check, is there any vertical column above this particular point C? Is there any liquid above this particular point C?
No, sir.
So pressure due to vertical column will be 0. Next, is there any horizontal component right side of this?
No, sir.
So you'll say yes, this particular term, which must be accelerated by A. So it will generate rho AL. This is A. And there will be no atmospheric pressure as well. Nabila, is it clear?
Yes, sir.
So what will be for this particular point D? First check, is there any vertical column above this particular point D?
No.
So there is no vertical column above this particular point D. So it will be 0, first part. Is there any horizontal component along this direction?
No.
No. And since this whole vessel is enclosed, so there will be no atmospheric pressure as well. So net pressure due to all these three different components for point D will be 0. Is it clear now?
Yes.
Yes, sir.
Nabila,
Yes, sir.
please ask if you have any doubt.
So can you explain once again from PC?
Okay. Since in this part, system is accelerating. In above part, I have just calculated pressure due to vertical column. And that vertical column must be accelerated by gravity. So you will say, if a fluid is accelerated along any direction, there will be some pressure due to this in opposite direction. So for this system, there will be two different acceleration. One is due to gravity and the other due to this particular E. Is it clear?
Yes, sir. Thank you.
So first, for A, check, is there any vertical strip present over that particular point A? So A, there is some vertical strip of length h, and along vertical direction, there will be acceleration due to gravity, which is g into h. Next, is there any horizontal component along this direction, which must be applying pressure to this particular point A? So you'll say no. So pressure due to horizontal acceleration will be 0. And last, is there any air column above that particular point? So you'll say no. This whole vessel is enclosed, so there will be no air pressure. Is it clear now?
Yes, sir.
Raza?
Yes, sir. Yeah.
Okay. Khalid, any doubt?
No, sir.
You all have written?
Yes, sir.
Now, there will be some other problem related to YouTube. Suppose you have like this. Initially, if you fill liquid from any one arm, horizontal level on either arm will be same. Then if you mix some other liquid, the level of liquid may get changed. Suppose there is a liquid which is filled initially, raised to this height. Another liquid is filled and the other so we have mainly three different liquid. This is row 1, this is row 2, and this is row 3. In equilibrium, the arrangement is this. Is it clear? So you will be asked to find density of any one unknown liquid. Next, vertical column of any one unknown liquid, or relative density of any one unknown liquid. So how to relate this particular U2 problem? So just check horizontal level. So we have first horizontal level at this point or junction, other horizontal level at this point or junction. Which one of these two horizontal level is at minimum or bottom? So you will say this term. So at same horizontal, lowest level, pressure on either arm in U2 must be equal. Is it clear? So just remember only this statement. So you'll say pressure in same liquid at same horizontal level will be equal. Or you will say at lowest horizontal junction, pressure will be same. At lowest horizontal junction, pressure in either arm will be equal. So let's say this is point A and this is point B. This particular term having vertical height h2, this term having height h1, and this term having height h3. So pressure at same horizontal level should be equal. So pressure at point A must be equal pressure at point B. Now check the amount of liquid which is generating net pressure at point A. So one will be due to the second liquid and the other due to air pressure above it. So you'll say at point A, there will be pressure due to air plus due to vertical column of this second liquid having height h2. Is it clear?
Yes, sir.
Any doubt? Just check for this particular point A. Since this whole system is at rest, so there will be only one acceleration due to gravity, which must be acting vertically. So there will be pressure at point A due to only vertical component. Is it clear? Now, for point A, Above it, there is liquid having density ρ2 and height h2. And above that, there will be atmospheric pressure due to air present above it. So net pressure at point A due to air plus this part. Is it clear, Ehtisham?
Can you repeat it again?
If you want to calculate net pressure at point A, since this whole system is accelerated due to gravity only, there is no horizontal acceleration. Gravity acts along vertical direction. So there will be pressure at point A due to only vertical component of fluid. Reza, is it clear?
Yes, sir.
Now check the amount of liquid or fluid placed above at this point A. So one is due to the second liquid and the other air present above it. So pressure at point A will be due to air plus this part. Mazia, is it clear?
Yes, sir.
Similarly, for point B, if you calculate, there is 3 different segments. One is due to this H1 amount of liquid, or this one. Second one, this is third, and also due to air present above it. So pressure at this B point will be due to rho G H1, that is first liquid, plus rho G H3, that is third liquid, plus atmospheric pressure. Nabila, is it clear?
Yes, sir.
Now, P0 and P0 will cancel out. Gravity is common whole term, so that will be cancelled out. So you'll get rho2 H2 equals to rho1 H1 plus rho3 H3. Using this, you will get the unknown part. Minashi, any doubt?
No, sir.
Okay, just write it down.
So where did gravity go again?
Since gravity is common on either side, so I've just taken out as cancel it.
Oh, okay, sir.
Once again,
Yes, Sham.
you can show the above part.
Okay.
Yes.
You all have written?
Yes, sir.
Suppose there is U-tube in which one of liquid is filled in left side and the rest of the thing is filled with water. And there is change or difference in level of liquid by 3 centimeter. So you have to calculate fine density of liquid. Just use the above concept. Pressure at same horizontal level at the lowest junction should be equal, which means at this horizontal level, let's say point A and point B, pressure will be equal. Just equate them. Density of air water is 1000 kg per meter cube. Apply it and try to solve.
So the 3 centimeter is air, right? It is,
Yes, Sham. Pressure at point A must be equals to pressure at point B. At point A, there is this liquid and above it is air. So P naught plus rho G H, column of liquid is 10 centimeter divided by 100 equals to, at point B, there will be atmospheric pressure plus density of water, gravity, and column of water is just 7 centimeter. Just solve it to find rho. Nabila, is it clear how I've just written this?
Where did you get 10 cube from, sir?
Density of water, pressure in this BR will be rho GH. Rho is density of water, that is 1000, 10 to the power 3.
Oh,
G,
okay, sir. Okay.
good at Sham. Raza, just check your calculation. P0 and P0 will cancel out. This gravity and this gravity will cancel out. So rho 10 upon 100, it will be equals to 10 to the power 3, 7 upon 100. Now this 100 and this 100 will cancel out. So rho will be equals to 7 into 10 to the power 3 divided by 10. So it will be just 700 kg per meter cube. Is it clear?
Yes, sir.
Mazia, any doubt? Minashi?
No, sir.
You all have written?
Yes, sir, done. Sir, for the force and this density thing, we don't need to write like in standard form, right? We can it then rest to do this stuff.
Your voice is not clear. For any problem or for any answer, try to write answer in terms of their SI unit and in proper notation. So this answer will be written in terms of 0.7 into 10 to the power 3 kg per meter cube, or you may write this part, but it should be in SI unit. Okay, Sham? So this is all about pressure and Pascal's law till this part. Do you have any doubt to any one of you? Nabila?
No doubt, sir.
Okay. Next is surface tension. To define this, let me define you some property or some interaction in liquid, which is called molecular interaction. There are two different types of interaction. First is adhesive force, and second is cohesive force. You must have learned about this in your chemistry in states of matter. So do you have any idea about these two terms? Raza? Adhesive force means force of attraction between different molecules. Adhesive force is force of attraction between different molecules. That's why Fevicol is adhesive liquid. Next, cohesive force is force of attraction between similar molecule. So there's two different types of molecular interaction. One is called adhesive and the other is called cohesive. Is it clear?
Yes, sir.
Nabila?
Yes, sir.
Now, on the basis of this, suppose there is a container in which liquid is filled up to this point. So if you consider a small spherical part and this well inside portion, so there will be particle, one at center and the other all around it, like this. So all its neighboring surrounding particle must be applying attractive force in all this direction. This particular attractive force is due to same or similar molecule. So you'll say this is cohesive interaction. Is it clear?
Yes, sir.
So for this centralmost particle, net force from all sides must be 0. Is it clear? You can say that. Nabila?
Yes, sir. Clear, sir.
Similarly, consider any other particle at this topmost point. Now, consider there is a particle at this centralmost part. So there is particle from only this direction or towards the lowermost part, which must be applying force on this centralmost. Since there is no any particle above this particular term, so there will be no force above it. So net force on this centralmost particle will not be zero in this case. Is it clear?
Yeah.
Sham, is it clear? Minashi?
Yes, sir.
So you say this top layered liquid is always experiencing a net force in downward direction or sideways, due to which it will have some stretched behavior. Is it clear?
Yes, sir.
Yes, sir.
Suppose you have string wire attached to any support. So to this particular slackness, there will be no tension. But if you apply force or attached any block, there will be straightness in this particular string by which a force get developed into it due to its straightness, which is called tension. In the same way, here for this top layered liquid, there is some straightness due to this molecular interaction from all its side towards downward direction. So this tendency of top layered liquid due to its molecular interaction is called surface tension. Is it clear?
Yes, sir.
So in this part, F net is 0, but for this part, F net is not equals to 0. So the top layered liquid film, a thin layer of liquid, behaves as stretched membrane due to molecular interaction. This is called surface tension. Nabila, any doubt?
No doubt, sir.
Mazia? Khalid, is it clear?
Yes, sir.
Okay, just write it down.
Okay, sir.
It's liquid film, means a thin layer of liquid. Behaves as a stretched membrane due to its molecular interaction you all have written?
Yes, sir.
Khalid,
Yes, sir.
you have written?
Yes.
Okay. So let's stop here till this. Do you have any doubt from today's class? So revise till this whole part and try to do problems as we discussed today. We'll start new topic in next class. I will define this particular term in more detail. Okay? Okay then.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Assalamu alaikum.
Assalam, sir.
How are you all?
Alhamdulillah, fine, sir. How are you?
Alhamdulillah, fine. So do you have any doubt from last class?
No, sir, no doubt.
We have just started conservation of angular momentum. On the basis of this conservation, there will be a question. Suppose you have two disks One is having axis this, rotating at some angular velocity omega. Moment of inertia of this disk is I1. Another disk having moment of inertia I2 is rotating along this vertical axis at some angular velocity omega 2. Now, if they two get gently placed over one another, this is having axis along this direction, which is placed gently over the second. Now they start rotating with some new angular velocity omega. Is it clear?
Yes, sir.
So we have to calculate angular velocity of this common part with respect to this term. Now I have just assumed rotation of these two disks along same direction, that is in anti-clockwise direction. But there will be question that the second disk must be rotating in opposite of first disk, so it have some angular velocity along this direction as well. So how to relate these two terms? So you'll say, since there is no any external torque acting on this whole system, so angular momentum will be conserved. So as torque acting on the system will be 0, so angular momentum initial must be equals to angular momentum final. Initially, first disk having angular momentum I1 omega 1, second disk having angular momentum I2 omega 2. If they will be rotating in same direction, then there will be positive sign. But if they will be rotating in opposite direction, so there will be negative sign. Is it clear?
Yes, sir.
So this is initial angular momentum of individual body. On combining, since moment of inertia behaves as scalar quantity, so it will be added or subtracted algebraically. So moment of inertia net will be I1 plus I2, and both rod or both disc will be rotating at same angular velocity omega. So on comparing these two terms, you will get omega or common angular velocity after combining will be I1 omega 1 plus or minus I2 omega 2 whole divided by I1 plus I2. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Okay. This is the first expression of calculation of angular velocity on combining them. Now there will be another question to find energy. In last class, I defined you how to calculate kinetic energy of rotating body. So kinetic energy initial to disk having moment of inertia I and angular velocity omega. So it will be half I1 omega 1 square. For second part, it will be I2 times omega 2 square. So this will be initial kinetic energy. On combining them, kinetic energy final will become half total moment of inertia times common angular velocity omega. So if you put the value of omega to be this part, you will get final kinetic energy. So it will be kinetic energy final equals to half I1 plus I2. This whole part I1 omega 1 plus I2 omega 2 divided by I1 plus I2 whole square plus or minus. So this term and this term, since this term having exponential 2, so one of the power will cancel out. So you will get half I1 omega 1 plus or minus I2 omega 2 whole square divided by I1 plus I2. So this will be a final kinetic energy for the system. Now, if you subtract these two terms to calculate change in kinetic energy from initial to final. So change in kinetic energy will be equals to kinetic energy initial find kinetic energy final. So on solving, you will get I1, I2 divided by I1 plus I2 times omega 1 plus or minus omega 2 whole square. It will be opposite of that above part. If here it will have plus sign, then it will have negative. If it will be negative, then it will be plus sign here. So this will be total amount of energy lost during combination of two disks or placing over one another. And this particular energy loss is due to the friction of the surfaces which is in contact. Is it clear? Hamza?
Sir, can you tell again the last part?
You will be asked why there is change in kinetic energy on combining the two disks together. So you will say this particular change in energy between initial and final is this much amount is due to amount of energy loss on combining two disks whose surfaces are in contact, which must be offering some amount of friction. So there will be amount of energy lost due to heat produced by that. Is it clear?
Yes,
so this
sir.
is called loss in energy due to friction offered by surfaces in contact. Salman, any doubt?
No, sir, for now, no.
Okay.
Sir, can you explain again? Like, I'm still trying to wrap my mind around the first one.
About kinetic energy.
No, the first one, like the first equation you got.
Okay, just 1 minute. First, write it down.
Sir, what did you write after friction? Friction offered?
Friction offered by the surfaces in contact.
Done, sir.
Done, sir.
Hiba, you have written?
Yes, sir, done.
Okay. Let me define you again about this. Initially, we had two different disks having moment of inertia I1 and I2, which is rotating at some angular velocity omega1 and omega2. The rotation of these two disks will be same or different. So I have taken both cases. On combining them together, this becomes single system. So both will start rotating with common angular velocity omega. So first we have to find this omega for this two system. So according to conservation of angular momentum, since there is no any torque acting on this whole system, so angular momentum initial must be equals to angular momentum final. Salman, is it clear?
Yeah, okay.
As angular momentum equals to moment of inertia into angular velocity, I defined this term in
Yeah,
last
okay,
class.
sir. Yeah, okay, sir. I understand. Like
So
the part,
total initial angular momentum is I1 omega 1 for the first part, and for second part is I2 into omega 2. If they will be rotating in same direction, there will be plus sign, or if they will be rotating in opposite direction of each other, then there will be negative sign. On combining them, angular velocity will become same. So I1 plus I2 times omega. So this omega is called common angular velocity. Now, on the basis of this term, I define kinetic energy. Kinetic energy initially of both this half I1 omega 1 square, half I2 omega 2 square. Finally, half I1 plus I2 omega square. If you put the value of omega from this part, you'll get this term. Now, if you subtract these two terms, this will define you change in kinetic energy. And since surface will be frictionless, then this particular difference must have 0. But now we have calculated the difference, and you'll get this particular amount of energy that will be evolved due to friction offered by the two surfaces in contact. Salman, is it clear now?
yes, sir. Like the first
Okay.
part was about how you got that equation. Now it's fine.
Okay. It was based on conservation of angular momentum. Now there will be another question related to this. You will be asked if glaciers of Earth would melt, how will time period or duration of day and night be affected? Can you imagine? Let me give you a hint how to simplify it. Suppose this is Earth having axis along this direction. So it must be rotating with some angular velocity omega. As we know, according to geography, glaciers would lie at this point maximum, northern pole and southern pole. So these two places the coldest on the surface of Earth. So we have glaciers on these two terms. Now, if it would melt, this is your axis of rotation. On melting glacier, this water will move to equatorial region. As you know, water body lies only on this region. So initially, the distance of glacier from axis of rotation is small. So moment of inertia for this part will be small. On melting it, they will reach to equator where distance from axis to this particular portion becomes farthest. So moment of inertia will increase now. Due to increase in moment of inertia, angular speed will be decreased. Is it clear?
Yes, sir.
Initially, due to the presence of glaciers on these two poles, distance from axis of rotation is small. So moment of inertia will be small, angular velocity will be large, and time of period of rotation of Earth will be always also small. But now on melting glacier, they will reach to equator so that distance from axis of rotation will increase. So moment of inertia will increase, angular velocity of rotation will decrease, and consequently, time period of rotation of Earth will increase. It means duration or duration of day and night will increase. Is it clear?
Yes, sir.
Salman, any doubt?
No, sir, no doubt in this question.
Okay. You all have written?
Yes, sir, done.
Khalid, any doubt?
No, sir.
Okay. Next is rolling motion. So let me define you about what do you mean by rolling. Suppose you have a ball. For which each point, top, bottom, or center, having same horizontal velocity along horizontal direction as v. So if velocity of each point is same in horizontal direction, then it is called pure translational motion. Next, if for this object, angular velocity of each point, this top point, this bottom point, or any side point, this angular velocity for this part is same, then it is called pure rotational motion. So for pure translational part, translational velocity or horizontal velocity of each point should be same. Similarly, for pure rotational part, angular velocity of each point should be equal. Now, if you combine these two different, so on combining these two terms, you will get first, due to translational part, there will be velocity at this point along this direction as v, and at this point as v, for this point v, this point as well as this point. All particles will have same horizontal velocity due to pure translational part. And for pure rotational part, there will be velocity along this direction due to omega. So it will be r times omega. For this part, it will be along this direction. For this part, it will be this and this. So on relating, you will say at this lowest point and at this highest point, direction of these two terms will be along same. So it will be v plus r times omega. And at this lowest point, they are different. So it will be v minus r times omega. Is it clear?
Yes, sir.
Iba, any doubt?
Yes, sir. So no doubt.
Okay. Now, on the basis of these two terms, we may define first, if translational velocity equals to rotational part, then it is called pure rolling motion. It means translational velocity and rotational velocity will be equals to each other. That is called pure rolling motion. And if v is not equals to r omega, that is called rolling with slipping. So you have to define only this first part. So what you can say about pure rolling for highest point? For highest point, since these two terms are equal, so it will become 2v And for lowest point, since these two terms are equal, so it will become 0. And for middle one, it will be just V. So there will be change in translational velocity for pure rolling body. Hamza, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Salman, you have written?
Yes, sir. I keep
Okay.
forgetting.
Now for this rolling motion, we have to define first kinetic energy of rolling body. Since this particular body will have two different motion, one is translational and the other is rotational. So total kinetic energy will be equals to kinetic energy translational plus kinetic energy rotational. Translational kinetic energy is due to horizontal movement, so it will be half mv square, and it will be due to velocity of center of mass plus the rotational term, it will be due to half times I omega square. We may convert moment of inertia in terms of the radius of gyration as mk square and angular velocity equals to velocity by r using the above formula. So you'll write half mv square plus half I is k square and omega is v square by r square. So half mv square is taken out as common. So you're left with 1 plus k square by r square. And this particular ratio I defined you in last class is also called beta. So you can write half mv square plus 1 plus beta equals to total kinetic energy. Is it clear?
Yes, sir.
Yes, sir.
So if you know the value of beta or radius of gyration, you can define amount of translational energy and amount of rotational energy present in that ruling body. First, write it down. I'm giving an example.
ये पूछ रहा था कि
You all have written?
और वहां उतरूंगा तो फिर वहां मतलब
Done, sir.
Done, sir.
So if you want to calculate fractional amount of rotational energy or fractional amount of translational energy for this total part, let me define you. So kinetic energy translational with respect to total kinetic energy. Translational kinetic energy is half mv square. Total kinetic energy is half mv square bracket 1 plus beta. So this term and this term will cancel out. So you'll get just 1 divided by 1 plus beta. This is also called fractional amount of translational energy present in that object with respect to total. Similarly, amount of rotational energy with respect to total will be equals to beta by 1 plus beta. Is it clear?
Yes, sir.
So this particular term will be fractional translational kinetic energy with respect to total kinetic energy rolling. Similarly, this term is fractional rolling or fractional rotational kinetic energy
वोल्टास में डायरेक्ट नहीं था
rotational kinetic energy with respect to total rolling kinetic energy. Let me give you an example. Suppose you have hollow sphere. Moment of inertia of hollow sphere is 2 by 3 times mr squared. So coefficient of moment of inertia, that is this fraction, is also called beta. So beta equals to 2 by 3. Now, if you put this particular beta in above kinetic energy translational divided by kinetic energy total, it will be 1 divided by 1 plus beta, which is 2 by 3. So it will be 3 divided by 5 or 0.6 bar. So if you multiply it by 100, you will get 60%. It means on rolling hollow sphere, 60% of its energy will be translational and the rest of 40% will be rotational. Is it clear? So
Yes,
kinetic energy translational with respect to total multiplied by 100 will be equals to 60%. It means for rolling hollow sphere, 60% of the total energy will be translational and only 40% of the total energy will be rotational. Khalid, is it clear?
Yes, sir.
So by using this formula, we can define amount of translational or amount of rotational part present in that rolling body. Hamza, is it clear?
Yes, sir.
Okay, just write it down. Hiba, you have written?
yes, sir.
Salman,
Yes, sir. Written.
okay. Find percentage kinetic energy rotational and translational. Just 1 minute. Find percentage rotational and translational kinetic energy for hollow cylinder. Moment of inertia of hollow cylinder is just mr square. Try to solve. Just wait 1 minute, I'm coming. Good, Khalid. Hamza, you have solved?
No, sir, I'm stuck.
Since I equals to mr square, so coefficient of mr square will be nothing but just 1. So beta will be equals to Iba.
1.
Good. So beta will be 1. Just put this value in above formula and multiply it by 100. You will get percentage translational and rotational energy. Okay. Try to solve. Good, Salman. As kinetic energy translational to the kinetic energy total multiplied by 100 equals to 1 by 1 plus beta multiplied by 100. Just put the value of beta and simplify it. Similarly, rotational divided by total multiplied by 100 equals to beta divided by 1 plus beta into 100. So if you put the value of beta in first part, you will get 1 by 1 plus 1, that is 2, multiplied by 100. So 2 in 50 times, so it will be 50%. Similarly, this will be also 50%. Iba, is it clear?
Yes, sir.
Hamza, any doubt?
No, sir. I've sent you the answer, right?
Okay, good. Now the next term is for inclined plane. Suppose there is inclination on which a ball or a sphere is placed like this. So first, for its rotational part, there will be some amount of friction which must be acting along this direction at its point of contact, which is at some distance r from the center, and it must be applying some torque on this body to rotate it. So the necessary condition for rolling of this particular body is friction. So if surface is smooth, there will be no rolling. So the necessary condition for rolling of body is friction. So you'll say friction provides necessary torque for rolling of a body on a surface. Is it clear? Khalid?
Yes, sir, clear.
Now, torque is equals to distance into force. And torque is also equals to moment of inertia into angular acceleration. So if you put the value of angular acceleration in terms of linear, it will be A by R equals to R times F. So on simplifying it, frictional force equals to moment of inertia into A divided by R square. Hamza, is it clear?
Yes, sir.
Now, net force acting on this particular body, one will be along this direction due to component of force of gravity. This is mg. So there will be one component along this direction inclined at some angle theta, which is mg cos theta, and another term along this direction, which will be mg sin theta. So mg sin theta will be responsible for accelerating along this direction by some acceleration a. So A equals to net force, that is mg sin theta, minus frictional force divided by mass of body using second law. So you can write ma equals to mg sin theta, and friction is I times A divided by R squared. You can write moment of inertia in terms of radius of gyration as mk squared. So it will be ma plus mk squared A divided by R squared equals to mg sin theta. I have written I as mk squared. Now, if we take out ma as common, so 1 plus k squared by R squared equals to mg times sin theta. Now m and m will cancel out. So you will get acceleration equals to g times sine theta divided by 1 plus k square by r square, which is also called beta. So this will be your net acceleration of body on inclined rolling surface or inclined frictional surface. Iba, is it clear?
Yes, sir.
Okay, just write it down.
Sir, we can put beta right instead of k square by r square.
Yes.
Okay.
Done, sir.
Hamza, you have written?
Yes, sir, done.
Okay. Similarly, if you use second equation of motion to find time, you will get time equals to 1 by sine theta root of 2h1 plus beta divided by gravity. Next, velocity will be equals to root under 2gh divided by 1 plus beta. Frictional force, which was Ia by r square, so it will be I is moment of inertia as mk square, so it will be beta divided by 1 plus beta times mg into sine theta, or if you simplify it, you will get mu static equals to beta divided by 1 plus beta into tan theta. So these are some expression obtained using this particular term. You have to remember 2 or 3 terms or as much as you can, but just remember this acceleration. Then you will get rest of the whole term. Is it clear? Khalid, any doubt?
No, sir.
Now, on the basis of these three terms, it will find you something as acceleration equals to g times sine theta divided by 1 plus beta. Time is 1 by sine theta root of 2h bracket 1 plus beta by gravity, and velocity equals to root under 2gh by 1 plus beta. So first is, these three conditions is for rolling. For smooth surface, beta will be 0. So if you put beta to be 0 in this entire part, you will get A equals to just g sine theta for this. T will be 1 by sine theta root of 2h by g, and velocity will be just under root of 2gh. Similarly, for free fall or free falling body, beta will be 0 and theta will be 90 degree. So if you put these two terms in this above part, you will get A is equals to G, T equals to root under 2h by G, and velocity will be as it is 2gh, which is similar as we have obtained in third chapter. Is it clear?
Yes, sir.
Hamza, any doubt?
No doubts.
Salman, you have written?
Yes, sir, done.
Khalid?
Yes, sir, done.
Okay. Next will be flywheel. Flywheel is nothing but a circular disc which is hanged from any rigid support vertically, from which a thread with mass attached is Suppose you have circular disc or cylindrical object, which may be hang or fixed at any rigid support, on which thread, rope, or massless string is twisted like this, or rotated around it like this, attached with some mass, m. So you have to calculate acceleration of this particular system. Let me define you how to approach. First, for this block part, there will be a force in downward direction due to gravity, that is Ng. And straightness of this particular string may get developed force that is tension. Now, due to this weight, there will be acceleration in downward direction, acceleration A. Is it clear? Now, you can write using second law, net acceleration is equals to net force, that is mg, minus tension divided by mass of block. On rearranging, it will be m times a equals to mg minus t. So this will be the first equation for this block, which is similar to what we have done in Newton's law of motion. Iba, is it clear?
Yes, sir.
Khalid, any doubt?
No, sir.
Now suppose for this disk. In 5th chapter, I have taken disk or pulley to be massless, immovable, and frictionless. But in this part, we have to take this particular term having mass and will rotate due to this motion. So there will be tension at this point along this direction as T, due to which there will be torque along this direction to rotate it from this axis of rotation, distance r. So torque will be equals to force into perpendicular distance, and this torque is also equals to I times alpha. So I alpha equals to A by R equals to R times T. So T will be I into A divided by R square. So this will be your net tension acting. Hamza, is it clear?
Yes, sir.
Now, if you put this value of tension in this equation, on solving, you get A equals to mg divided by m plus I divided by r squared. So this will be your net acceleration of block using this particular flywheel part. I have just put the value of tension in this equation and simplified it to find acceleration. Khalid, any doubt?
No, sir.
Okay. You all have written?
Just the last part, sir.
Okay.
Done, sir.
Done, sir.
Salman?
Yes, sir. Done writing.
Okay. Now let me give you a question related to this. A circular disc having mass 10 centimeter. A block of mass 5 kg attached to string is hanged is whirled around disk. So find acceleration of block tension in string. Just use the above formula and try to find. Moment of inertia of circular disk is mr squared. I is m times r squared by 2. Mass is given. This mass of disk is capital M, or let's say small m. Mass of block is 2 kg. You may write it as M1, M2, according to your choice. Capital M is 5 kg. Just use the above formula and try to simplify. First, put the formula is mg. In this part, m is the accelerating mass, that is the larger block. So it will be capital Mg divided by capital M. Moment of inertia of disk is mr square by 2 divided by r square. So this r square and this r square will cancel out. Now put all values and try to simplify it. Then for tension, which is equals to IA divided by r square. If you put the value of I to be moment of inertia of disk, mr square by 2 divided by r square into A. So this and this will cancel out. Put the value of small m, A, and simplify it.
So do we have to convert kg into grams?
kg is a SI unit.
Okay.
Let's just check a question. You have given mass of disk to be just 2 kg. Mass of block is 5 kg. Acceleration due to gravity is 10. Try to solve again using this. Khalid, your answer is correct. Salman, check your calculation.
What, sir? It's correct?
It was correct. Capital M is
Okay.
5, G is 10, capital M is 5, small m is 2 divided by 2. So this 2 and this 2 will cancel out, so it will be 1. 5 into 10, 50, divide by 6. So it will be 25 by 3 meter per second squared. Good, Salman. Good, Hamza. On putting this term in this part, tension will be equals to 2 divided by 2 into acceleration, 25 by 3. So this and this will cancel out. So it will be again 25 by 3 Newton. Any doubt till this part?
No, sir.
Iba? Salman?
No, sir, no doubt.
So this is all about this rotational motion. Okay? Hamza, do you want to ask something or any topic related to this whole chapter?
No, sir.
Okay then. So start with the second or new chapter. Gravitation. First is universal gravitational law. Suppose if you have any 2-point masses, M1 and 2, separated by some distance r apart. So according to this universal law of gravitation state, every object in the universe which having some mass m will attract the other having mass m with a force or attractive force which is called gravitational force. And it will depend upon first product of mass of either body, and it will be inversely proportional to square of separation between them. So first is about universal gravitational law. Every object having mass attracts the other by a force called gravitational. It is directly proportional to the product of masses and inversely proportional to the square of their separation. Salman, is it clear?
Yes, sir.
So gravitational force F is directly proportional to M1, M2, and it is also inversely proportional to square of separation between them. So if you combine these two terms, you will get F equals to, by removing this proportionality sign, by any constant capital G, M1, M2 by R squared, where G is called universal gravitational constant, which is equals to 6.67 or 20 by 3 Newton meter square per kg square. You either use this decimal part or this fractional part for different calculation. Is it? Just write it down. You all have written?
Done, sir.
Salman?
Yes, sir, done.
Now, there is some property of this particular gravitational force. First is, it is always attractive. Next is, it will be medium independent. Which means if this entire system is immersed in a fluid or water, the gravitational force in between two particles will remain same. So it will be same either in vacuum or either placed in any other medium. Gravitational force will remain same. Next is, it acts along line joining between their center. So it is also called central force. Hamza, any doubt?
No, sir.
Okay. Just write it down. Try to solve this part. You all have written this question? Hamza?
Yes, sir.
So what will be your answer? Khalid?
Yes, sir.
What will be your answer to this question? Just see, I've defined you above in this part. Gravitational force is medium independent. It means if you change the surrounding medium of the containing particle, then gravitational force will remain the same. So initially it was in vacuum for which gravitational force is F. Now it is immersed in water, so gravitational force will still remain same. So gravitational force in water will be remain same. Is it clear?
Yes, sir.
Iba, is it clear?
Yes, sir.
If two identical spheres having mass density as rho and radius r is placed touching each other. Find the relation of force and separation. Suppose you have two identical spheres. This is first and this is second. Now they are placed side by side. So this is distance from this point to this point. So total separation between their center will be R plus R. So if you calculate gravitational force in between them, so force is equals to G product of their masses divided by square of their separation. So it will be G times m square divided by 4 times R square. Hamza, is it clear?
Yes, sir.
But in the question, you have given in terms of density rho. So we convert this particular mass in terms of density, as density is equals to mass divided by volume, and volume of sphere is 4 by 3 in pi r cube. So mass will be equals to 4 by 3 pi rho times r cube. Just put this value of mass in this part, you will get G m square. So it will be 16 pi square rho square r to the power 6 divided by 9 whole divided by 4 r squared. Khalid, is it clear?
Yes, sir.
Now on simplifying, this 4 and 16 will cancel out in 4 times. We have r square in denominator and r to the power 6 in numerator. So on simplifying it, you will get 4 pi square rho square into G whole divided by 9 times r to the power 4. This whole term is constant. Force is equals to this much. Now, how is force related with R? Hiba?
That is directly proportional.
R to the power 4. So it will be F proportional to R to the power 4. But we have learned above about gravitational force for any 2-point masses, as they will be inversely proportional to R square. Is it clear? So in the above part for point masses, in this part, we had force inversely proportional to R square. This is only possible if masses are point and they will be separated at some distance R. But in this part, 2 spheres are placed side by side, and I have calculated force in terms of density. That's why force is related with R like this. Is it clear?
Yes.
Yes, sir.
Okay. You have written Salman.
Yes, sir, done.
You all have written?
Yes, sir.
Okay. Let me define you one last question related to this. There will be a question. If body having mass m is split up and m minus m and separated at d distance. Find relation between small m and capital M so that force is maximum. Let me define you how to solve this problem. In this part, we have a body initially having mass m. Suppose there is a body having mass m initially, split up into two parts, one having mass m minus m and separated at some distance d apart. Hamza, is it clear?
Yes, sir.
So we have to calculate force in between, as force between any 2 point masses separated by distance d is g times product of masses, so m1, m2 by square of their separation d square. So on simplifying it, g over d square is constant. So if you multiply it, it will be m times small m minus of m square is equals to this f. Is it clear?
Yes, sir.
Now you'll be asked, is this force is constant or variable? So you'll say it will be variable and small m dependent, as small m is variable term. So we have to calculate value of small m with respect to capital M so that this force will be maximum. I defined you in calculus part for differentiation integration how to define maximum or minimum of a function. Khalid? Do you have any idea how to get maxima or minima of a function? Hamza? I think your examination is going on. That's fine. Good. For function to be maximum or minimum, its differentiation should be equals to 0. Okay. So in this part, we have to find maximum value of force, which means the differentiation of force with respect to that variable part on which it is depending upon should be 0. So in this part, force is depending upon this small m, which is variable. So for maximum, df over dm should be equals to 0. Now let me differentiate it. So F equals to G over D times or D square, M into M minus N squared. So if you differentiate it, dF divided by dm, G over D square is constant. Capital M is constant. So if you differentiate M, small m to the power 1, so it will be just 1. Differentiation of m squared, it will be just 2m, and equate it to 0. Hamza, is it clear?
Yes, sir.
Khalid, any doubt?
No, sir.
Now, since this coefficient will be a constant term, so this term must be equals to 0. So m minus 2m equals to 0. So small m will be equals to m by 2, which means if masses will be divided equally, then force in between them will be maximum. Eba, is it clear?
Yes, sir.
Okay, just write it down. Salman, any doubt?
No, sir.
You all have written?
Yes, sir.
Yes, sir.
Any doubt till this part?
No, sir.
No, sir.
So let's stop here to this part. In next class, we'll start gravity and Kepler's law. Okay. Hamza, do you want to ask something?
No, sir.
Okay, good luck for you for examination.
Thank you, sir.
Okay then, Allah Hafiz.
Okay, thank you, sir. Allah Hafiz.
Thank you, sir. Allah Hafiz.
Sir.
Allah Hafiz.